In 4.1b, we are going to talk about the graphs of linear equations. Now remember, you should know by now how to graph a linear equation. You can use the slope and the y-intercept. That's one way to do that. Remember, the y-intercept is technically a point, so this is the point 0b, and that your slope you can do rise over run. Or you can make up a table because it's a linear equations and you can plot some points and you could graph them there. Now, just like any of our other transformations, we can have vertical stretches or compressions. I'm sorry, these headings are totally reversed, so if you want to make a little arrow. This is the vertical stretch or compression, and this is a vertical shift. The slope is actually in charge of compressing or stretching your graph. You'll notice here that all of our slopes have changed. So the slope will change or compress our graph. And then the vertical shift is related to our b. Whatever our number here is, it's on the outside of the function. If we add, it's going to go up. You'll see the purple one is up 4, and then the orange one is up 2, and so on. Or if you subtract, it's going to go down, so down 2, down 4. And so vertical shifts are a change in our y-intercept, so that would be those things. Vertical stretches or compressions are a change in our slope. Now, the slope is a very powerful part of our linear equation. It can tell us whether our function is increasing, decreasing, or constant. An increasing linear function has a positive slope. A decreasing linear function has a negative slope. And a constant linear function has a 0 slope. Now, a vertical line is not a function at all, so it wouldn't be considered in our slope sort of idea. So let's practice graphing some lines. This should be very easy for you. We're going to do it 2 different ways. We're going to make a table for one. We are going to use the slope and the y-intercept for the other. So for this equation, let's make a chart. Let's find our intercepts. Because this is what's in standard form, which we haven't talked a lot about standard form. Standard form is ax plus by equals c, where a, b, and c are non-fractions. They are integers. A is positive usually, and they have no common factors. So that's kind of standard form. But anyway, this line here, question 4, is in standard form. So if I see the ax plus by equals c, I usually tend to use a table. I'll plug in x equals 0, and when you do that, you get 0 minus y equals 4, so negative y equals 4. You'll notice that y equals negative 4. And then if you plug in y equals 0, you get x minus 0 equals 4. So x is equal to 4. So it's usually mathematically a very nice thing to do for a equation in standard form. Just plug in 0 for x, 0 for y, you get the intercepts, and it's very easy to graph. So you'll notice we have 2 points here. Our y-intercept is at the point 0, negative 4. Our x-intercept is at the point 4, 0, and we can graph our line. Then you can answer questions about the line if they have asked you. You know, we just found the x-intercept was 4, 0. The y-intercept was 0, -4. And we can use the graph of the line. This is an increasing line with a slope of +1. So by just being able to graph the line, we know lots of information about our line. Now, question 5, I would probably not graph it the same way. Now, could I? Of course I could. You can always plug in points at the line. You do whatever that, yeah, most equations you can plug in some points, at least to give you an idea of what the graph is going to look like. But in this equation, because it is in that slope-intercept form, why not use that to your advantage? So I know my slope is -2/5. My line should be decreasing. I know that my y-intercept is 2, so it's going to go through the point 0, 2. So in that case, I would use that as my starting value, my initial value, 0, 2. And because slope indicates rise over run, you're going to go down 2 and to the right 5 from that point to find another point on your line. So down 2 over 5. And then make your line. Now, I am not a very neat grapher, so I tend to sometimes really try to stretch my graph across my graph paper so that I get a slightly better indication of what my line is doing. So that is your line for that one. So graphing lines, you have lots of power as to how you do it. We know lots of things about the equation of lines. So if you want to graph it with plugging in some points, if you want to graph it using your slope and your y-intercept, do it. There's nothing wrong with either method. Some is just more convenient than others. Let's take a look at this one. Now it says to match each equation of the linear function with one of the lines. Okay, so first let's look at our lines. We have positive slope, positive slope, positive slope. The only one that has a negative slope is this one. So the only equation I see up here with a negative slope is C. Now let's just verify that this is graph C right here. Well, it should start at 3, go down 2 over 1, down 2 over 1. It is our only decreasing line, and that's exactly what happens there, okay? So that C is in blue. They called that line 4. Okay. Okay, now if we look, the only other points that go through the only other points that go through 3 are these two. You'll see they both have a y-intercept of 3, but this slope is not as steep, so I would assume it's this orange one. And does its slope go up 1 over 2? Well, let's check. From this point, up 1 over 2, up 1 over 2. This line in orange is line 3. Now, the line in red, line 1, should be this one. Does it start at 3 but go up 2 over 1? See how it has a steeper slope. So yes, this is line 1, and that one is in red. Now we still have the line in green, so I would assume that this line here is the one in green, which they have labeled that as line 2. But let's just check. Starts at 3, -3, I'm sorry. It goes up 2 over 1, up 2 over 1, up 2 over 1. So that matches that one. So we have found all of the lines that match the given equations. Now, let me remind you, we've talked about this many times before, that a horizontal line has a equation, y equals a number, y equals b. It has a slope of 0, and you can also write it as f of x equals b. That's our constant function. Vertical lines are of the form x equals a number. The slope is undefined. So if they say to write an equation of the line graph, the first thing you want to notice is the fact that it's a horizontal line and that our y value is stuck at -4. Now, if our y value is stuck at -4, that is the equation of the line. It's always going to be y equals a number. Now let's take a look at the difference in 17. 17, the x value is stuck at 7. So you can see here, I'm smack dab in the middle of 6 and 8. My y value is, or my x value is stuck at 7. That is the equation of the line. That's how easy vertical and horizontal equations are. So a horizontal equation is always going to be y equals a number. You could even write it as f of x equals a number. The equation of a vertical line is always going to be x equals a number. So these are just, you're going to graph these for me. Please tell me the slope, the y-intercept, and whether it's increasing, decreasing, or constant. Okay. Or if it's not a function. So that's your 4.1B homework. And we also are going to do 4.1C. So let's take a look at this one. 4.1C is about systems of equations. So systems of equations, there are 3 types of systems. If it is consistent, it has an answer. So just think of consistent has an answer. So if you graph it and the 2 equations line up at exactly 1 point, this one would be consistent, independent. Because independent of what I do, they're always going to cross at that 1 point. If I draw the first line and then the other line overlaps perfectly, that is consistent, dependent. And then our last case is if we draw one line and the other line is parallel to it, then that would be no solution. So this one would have infinite solution. And then this one would have no solution. So one solution, infinite solutions, and no solution. Now you can check these by graphing them, but we want to see what happens with the algebra. So in this problem here, if they say 2 systems are given, and for each system choose the best description, and if applicable, give the solution. So there are 3 things to look for. They're parallel, they don't overlap at all. They have one place where they intersect, Or maybe they just are going to have infinite solutions that satisfy either equation solved for y. Okay, so what do you do? Well, the first thing I would do is I would look at my system. Let me write them down. You'll notice that we have the x's lined up, the y's lined up, the equal, the numbers. That's a really good system to use what's called elimination on. So your goal is to get one set of either x's or y's to be opposites. You'll notice that those are opposites. Since they are opposites, just add the two equations together so that they are eliminated, and we get 0 plus 0 equals 0. So 0 equals 0 means that there is infinitely many solutions. No matter what, I always get a true statement. So if you graph the lines, it's just that the lines are duplicates. So you're going to choose this one, but you have to tell them what is y equal to. So just take either equation and solve for y. I'm going to take the bottom one and solve it for y. So we'll just solve for y. So I get that 4y equals x plus 4. Divide everything by 4, I get 1/4 x plus 1. So 1/4 x plus 1. And if you did that for either equation, you would get y equals 1/4 x plus 1 every time. Okay? So that means that the equations are duplicates, they overlap, they're exactly the same equation. And think about it, if I multiplied this bottom equation by -1, it turns into the top equation. Perfect match. When they're perfect matches, there's infinitely many places that they overlap, and they must satisfy one of the equations if you solve them for y. Now, for system B, right now they don't look as if they are perfect matches. We can use elimination again. Let's take this top equation and do a little bit of magic to it. Let's just move the 6 over and make it positive. So we'd get -x plus 3y equals 6. I'm going to put the other equation underneath it. I already have opposites going on, so I'm just going to add the two equations together. I get 0 plus 0 equals 12. Now, last I checked, 0 was not equal to 12. So that would be the choice. The system has no solutions. So that's what it looks like if you try to go to solve the system and you get a true statement, 1 equals 1, 2 equals 2, 0 equals 0, you're going to choose infinitely many, and then just rearrange one of the equations, solve them for y. If you do the math and you get nonsense, 0 equals 12, which is never true, that tells you there's no solution. So now that we've seen one that the lines are just duplicates, or the lines are parallel and never touch, now it's time to look at one where we can actually solve it. So if I see an equation like this, where this system, the x's line up, the y's line up, the equals line up, the numbers line up, I think it's a really good system to try what's called elimination. Now, our job is to eliminate either the x's or y. You decide. If we want the x's to be eliminated, you would need to change them to be opposites. So what is a number that both 5 and 2 go into? 5 times 2 is 10. So I could change them into 10s. I could also change the y's into 2's. So I'm going to do that. I'm going to multiply this top equation through by -2. And I'm going to do it over to the side here. I have to multiply everything through by -2. So I get 4x minus 2y equals 16. And then I'm going to write the other equation unchanged underneath it. Now I know I am ready to go if I've got some opposites. Remember before we were looking for opposites. So those are opposites. It can either be your x's or opposites or your y's. Doesn't matter. Make them opposites. So those are opposites. So now I can add the two equations together. I get 9x equals 18. And that's an easy thing to solve. I'm going to divide both sides by 9. I get x is equal to 2. So that's what x is. But this is a system of equation where we are looking for a point of intersection. So we need a y value. Now you can plug into either equation. I'm going to use this one. So where the x is sitting, I'm going to put in a 2. So right here, I'm just going to put in a 2. And then I'm going to do algebra. So I get 10 plus 2y equals 2. Subtract 10 from both sides. I get 2y equals negative 8. Divide through by the 2, I get y is negative 4. My answer is an ordered pair to negative 4. Now, how could you check your work? Well, you could put this stuff in Desmos. You could put these two equations. Do they hit each other at 2, negative 4? You could plug 2, negative 4 into this. You better get negative 8. 2, negative 4 into this. You should get positive 2. That means they are the point that they have in common. Now let's do elimination again on question number 10. On question number 10, if I use elimination, I either could make the x's turn into 21 or the y's turn into 6. Doesn't matter. Neither is better than the other. 6 is smaller than 21, so I tend to sometimes inch toward the thing that's smaller. So let's multiply this top equation by 2 and the bottom equation by 3. Now remember, we need them to be opposites. So that'll make this a 6 and this a negative 6. That's what I'm looking for. Now you do it to every piece of your equation. So we get 14x plus 6y equals 48. Negative 6x minus, if I could multiply, let me go back for a sec. We're multiplying by 3. I get negative 9x minus 6y equals negative 48. The x's are 5x. The y's are opposites. That's exactly what we wanted. That tells us we're on the right track. And that equals 0. 0 divided by 5 is okay. It's just the number 0. 0 is a legit answer. I can't divide by 0, but I can get an answer of 0. Okay, so now x is equal to 0. We're not done until we get a y that matches it. So let's put x right there as 0. Could be either equation, doesn't matter to me. You get negative 2y equals negative 16. When I divide both sides by negative 2, I get 8. So that is the point 0, 8. Now, how could you check your work? Well, you could put both equations in Desmos. Do they cross at 0, 8? If you plug 0, 8 into the top equation, you get 24. If you plug 0, 8 into the bottom equation, you get negative 16. So 0, 8 is our solution. So that is one where you have just one solution. Let's do this one. We either have to turn those into 12. The number that 3 and 4 both go into are 12. One, make it a positive 12, one a negative 12. We can make that 10. I'm going to do that. So I'm going to multiply this one through by 5 and this one through by negative 2 because I want it. This one will turn into a 10. This one will turn into a negative 10. Remember, we want opposites. So we get 15x plus 10y equals negative 105. We get negative 8x minus 10y equals positive 42. You will see these are opposites. That's exactly what we wanted. So we're good to go. So now just add your equations together. Now when I do that, 15 minus 8 is 7x. Y's are gone. Negative 105 plus 42 is negative 63. Divide by 7, x is negative 9. Now, we're not done. This is a system. This is a point of intersection. So you can plug in 9 to either equation. I'm just going to put it right there. So we get 4 times negative 9 plus 5y equals negative 21. Now 4 times 9 is 36, so we get negative 36 plus 5y equals negative 21. Now remember, we're going to add 36 to both sides because we want that y term by itself. We get that 5y equals positive 15, so y is equal to 3. Now this is an ordered pair, so if we were to graph these two equations, they should intersect at the point negative 9, 3. So those are solutions to those. If you want to write those down, then you can have that as a way to check your work. So question 12, the answer would be 0, negative 1. 13, the answer is 1, negative 2. 14, the answer is negative 5, negative 4. And 15, the answer is 0, negative 5. So those are just same ones similar to what we've just done. And then your homework is here below. You have those 8 systems of equations. I do want to do number 5 with you here and number 18. So go ahead and let's pull up the homework and let's do number 5. Now number 5 through 8 at the top uses what's called substitution. So I want to do one like that. Substitution is nice because if you have one equation solved where it says either x equals or y equals, we can actually plug that into the other equation. Now we know that y equals 4x minus 9. So where the other equation holds the y, just stick in 4x minus 9. So we get 4x minus 9 equals x minus 3. And then that's just an equation, multi-step equation, solve for x. So let's subtract x for both sides. We get 3x minus 9 equals negative 3. Add 9 to both sides. You get that 3x equals 6. And once you divide by 3, you get x. Now you're not done until you find the y. Now what's great about substitution is you usually have at least one equation that says y equals the x value we just found minus 3 or negative 1. And then please write your answer as an ordered pair. So the answer is negative 1, 2. So that's number 5. Now I wanted to talk about how to do a problem like 18 that has a fraction in it. Now you were allowed to manipulate the equations first to get them the way you want. So there's a few things wrong with this bottom equation. One, fractions are ugly. We're going to fix that. And then our order's all off, okay? So let's take our first equation and make it x, then the y equals a number. So I'm just going to rearrange that, okay? Now the next thing I'm going to do is the common denominators between 9 and 18 is 18. That is the least common multiple that both 9 and 18 can divide into, 18. Now when I do that, I get 18. Now 18 times 5 is 90, divided by 9 is 10. Here, the 18 and the 18s are going to cancel out, just leaving me with negative 7y. Or negative 7, that's an x, negative 7x. And then I'm going to put the x's first, then the y's equals the numbers. Okay, now I got my system looks much, much better. So let's turn the y's into, let's think about it here, let's say they both would go into 60. So I'm going to make this a positive 60 by multiplying everything through by negative 5. And I'm going to leave this a negative 60 by multiplying by 6. Okay, so I'm going to multiply everything on top by negative 5. I'm going to get 40x plus 60y equals 120. And now I'm going to multiply everything. Oh, I'm sorry, that would be a negative 120. Because that's a negative 5, it would be a positive, positive, negative. Okay, Now let's multiply everything in the bottom by 6. So 7 times 6 is 42, so that's a negative 42x. 6 times negative 10 is negative 60. Look, oh, they're opposites. That's perfect. And then 6 times 18 is 108. Now we're ready to add them up. So as soon as we get them to have one pair that are opposites, we're ready to go. So we get negative 2x equals negative 12. So x is 6. Now I'm very hopeful because I got that nice number. Now don't expect every one of them to be nice, but that's a good sign. So let's go back and plug this into the first equation we started with. Go back to the start. It's usually a good chance that if you made a mistake, that could fix it or catch it. So we have negative 24 minus 8 times the x value we found equals 12y. So negative 24 minus 48 equals 12y. Negative 72 equals 12y. Divide by 12, you get negative 6. Our point is 6, negative 6. So even though we had fractions to start with, multiply through by the common denominator, make it a nicer equation, get those two equations in x, y equals a number order, and then eliminate. So that is the 4.1 notes all done. Thanks for watching. Have a good day.